Okay, engineering students, let us proceed from where we left last time. Now, I want to look at the order of precedence of functional groups. The IUPAC came up with a ranking, uh, meaning that if you're going to have more than one functional group, you need to use this rule to be able to say this the main functional group. By you saying it is the main functional group in the name will the name of that compound which you're going to be naming will end with that compound as the main functional group. For example, if the carboxylic acid is the main functional group, then the name will end with something like an alkanoic acid. If it has two carbon atoms, then the name is going to end with ethanoic acid. That's what I'm saying. That is the suffix. It means that is the main functional group. Yeah. So alkan means that that is the R group. It means you are talking about that which you are going to be naming here is going to be like the prefix, so that if I'm talking about like oic acid, you have an alkan, then oic acid. If you have alkan, then you add al, it becomes alkanal. If you had alkan, then on, it becomes alkanon, alkanol, alkan, amine. I'm talking about something like methyl amine. If you're talking about an alkyl group and then an amine, something like that. Yeah, yeah. So so what you're going to see here is that the carboxylic acid has got the highest priority. There are other functional groups that you're going to be encountering, notably another one called an ester group. An ester is, sorry if there are ladies hearing and we may say, hey, why are you mentioning my name? My name is Esther. So there's a difference between the Esther for the ladies, whereby is ESTHER. That is the Esther for the ladies, but for the organic compound, the Esther doesn't have an H, so it is ESTER. I don't know why they came up with such a name which is similar to a lady's name, but we'll leave it at that. So such kind of compounds, you're going to call them like the ester is going to be a derivative of a carboxylic acid. So we'll be mentioning it under the derivatives of carboxylic acid. It means that you have the carboxylic acid and then you do something and then you attach, you change one of the groups, like in this case it is the OH, so that you're going to convert the carboxylic acid into an ester. Yeah, but that one is something we'll be looking at later when we'll be talking about soaps and detergents. You're going to say they are going to be derivatives of the carboxylic acid. Now the next group, so in this case you can say 1 being the highest ranking, so 7 it means that is the lowest ranking. Yeah. So the next one we're going to see the aldehyde. The aldehyde, this is the general formula. As you said, an alkyl group, we're going to give it the letter R. So you're going to see this R group being repeated here. So the general form for the aldehyde is R, C, double bond H. So the suffix, it means that for the aldehyde, the name will end with Al. If aldehyde is the main functional group, the name will end with Al. For example, like alkanal. For example, like if it is methane and then it's got a carbon double bond H, carbonyl group, then the name will be methanol. Now, as a substituent, somehow there are two ways of naming. There is the former way, which is still available in some of the textbooks. You're going to see the aldehyde group if it is a substituent. By talking about a substituent, you're talking about a structure, an organic structure. It can contain, for example, the highest priority group, which is the carboxylic acid, and then somewhere in the structure there is an aldehyde. So in some textbook you may see the name formyl, Formyl. You're going to see the name formyl. Okay, but in some you are going to see the name oxo. What can you see here? The name oxo is appearing under aldehyde and also under ketone. And I will be explaining later how you can use the oxo for the aldehyde and also for the ketone. But just in a nutshell, if the aldehyde group is at the same position as the total number of carbon atoms, for example, if I'm dealing with something like butane, CH3, okay, let me put it in red. In red, it will be clear. Maybe I've got a CH3, a CH2, maybe I've got a CH2, and then this is where I want to put my carbonyl group, yeah? Can you see one? CH3, CH2, CH2, then maybe there's a carbonyl group, yeah? So in this case, if where there is the CH3, that's where I'm going to put my carboxylic acid. That means that I'm going to start numbering from 1, 2, 3, and something like that. If there is nothing else after this carbonyl group, which means that I'm going to put a hydrogen, then 1, 2, 3, 4, then the oxo group is on carbon number 4. Oxo group is on carbon number 4. If it's on carbon number 4, then and there is nothing else, then the only thing here has got to be an aldehyde. So if I'm going to say a 4-oxo butanoic acid, then it's very clear from the name that you're talking about an aldehyde group, because the aldehyde group, the oxo group, is on the last carbon. It means there is nothing else except putting a hydrogen at the end. So yeah, so in that case you can use the oxo group to denote an aldehyde group. On the other hand, if there is the carbonyl group is at any other position, for example, assuming here I had a CH3 here, and then probably on carbon number 2, on carbon number 3, I put a carbonyl group. So what type of functional group is this? It's a ketone, because there is a carbon and there's a carbon on this side. So this is a ketone. So if I'm going to use the word oxo, this will be carbon number 1, 2, 3. So it means that the carbonyl group is not on carbon number 4, but it's on carbon number 3. Is that okay? So in this case, you're going to say this is a 3-oxo. So what it means is this: if you're going to have something like a carboxylic acid, for example, if I may say I've got a carboxylic acid, like which one? Like a hexanoic acid, yeah? Hexanoic acid has got 6 carbon atoms. So if I have an oxo at a position other than carbon number 6, then that one will be referring to a ketone. Because that carbonyl group, that oxo, will have a carbon on one side and a carbon on the other side. But if it's something like a hexanoic acid and then I've got an oxo on carbon number 6, then the oxo will have to be an aldehyde, because there is nothing else on this other side, I mean at the end, because it's on the terminal carbon. So that's why you can use the oxo to denote either an aldehyde. Excuse me. Excuse me. Let me take some water. Excuse me. Okay, sorry. So, okay. So in this case, so you can use the oxo to denote the position of a ketone, which will be on the number of carbon atoms, which will be on a position other than the terminal position. For example, if I'm talking about heptanoic acid, that means it is 7 carbon atoms. So if I'm going to say I have a 7-oxo heptanoic acid, then it means that oxo which I have at the 7th position is an aldehyde. But if I have something like a 6-oxohexanoic acid, no, heptanoic acid, then it means that is a ketone. Yeah. But you're going to be looking at those examples. Yeah. Okay. Now, the next functional group that you're going to be looking at is an alcohol. An alcohol, you are going to see it is at a lower ranking than either an aldehyde or a ketone or a carboxylic acid. Okay? That tells you if you're going to have an organic structure, it has a carbonyl group, or it has a carboxylic acid, and then it has an OH. Then in this case, the OH for the alcohol will become a substituent. Now, can you see there is the suffix means that is the main functional group. Now there is a column at the end. Okay, let me delete this one in red because it is obstructing. I've already finished that explanation. In this case, we are saying if the alcohol group is a substituent, the name changes from an alcohol to a hydroxy group. Yeah. For example, you can have a hydroxy group as a substituent on a ketone, as a substituent on an aldehyde, as a substituent on a carboxylic acid. Are we together? Okay. There is the O and E which are deleted. Then there is the amine. Amine is at a lower ranking than the alcohol. An amine is generally said there's an alkyl, but then there's an NH2. In this case, you are talking about what? This is the nitrogen with 2 hydrogens. You're talking about a primary amine. As I've said, in this course, we'll be focusing on primary amines. But amines can be secondary, they can be tertiary, they can be quaternary. Yeah? But in this case, you'll just focus on the primary amines. Yeah? So when it is the main functional group and there is no alcohol, there is no ketone, there is no aldehyde, there is no carboxylic acid, then the structure will end with the name amine. Even if there is something like a double bond or something like that, and you're going to see if you've got something like a benzene and then there is an amine, you're going to see what name you're going to get. It means something like a benzene and an alkene, alkyne, they're going to be lower in ranking than an amine, an alcohol, a ketone, aldehyde, or a carboxylic acid. Yeah? When an amine group, NH2, is a substituent, then the name changes to an amino substituent. Okay? Amino substituent. Then, for the sake of simplicity, we're just going to put this one containing the double bond or the triple bond together. But at this point, we'll just try not to have an organic structure containing a double bond and a triple bond. But if you've got a structure containing a double bond and a triple bond, an alkene functional group has got a higher ranking than a triple bond. Yeah. Yeah. So, but let's just say we've got a structure. All of these groups here, they contain a benzene group. Yeah. So when there is none of these functional groups, then the name of that organic structure will end with benzene. Yeah. If you've got a structure containing a double bond, then the name will change will end with E, so that what you're going to have is that rather than have an alkyne, you're going to have what? I'm going to use the word ALK. So that the name will be alkene, alk, YNE. It tells you there is a triple bond or there is a double bond. If it's a triple bond, the name will end with YNE. If it's a double bond, it will end with ENE. Okay? And then if the double bond is going to be a substituent, then rather than you having something like an alkane, you're going to put ENE in the structure if there will be a double bond, or it will be YNE if it will be a triple bond. But you're going to be seeing these examples. Now, the new information here, which I want you to notice is, as I mentioned, there is the amine, alcohol, ketone, aldehyde, and a carboxylic acid. Sometimes you can have those structures containing a benzene structure. What I want to bring it out here is that when you've got something like an amine, an alcohol, ketone, aldehyde, or a carboxylic acid containing a benzene, then the benzene will be taken as a substituent, and then the benzene will be referred to as a phenyl. P-H-E-N-Y-L, phenyl. When the benzene is a substituent, the name changes from benzene to a phenyl. Yeah? To a phenyl group. Now then the last thing in this ranking is, if you've got any of these structures, there is a CH3, a CH2, a CH3, an ethyl group, propyl group, butyl group, and the rest. So all of the ones which are shown at number 7, if you can see, alkyl, halogens, and ethers, those ones do not have any priority over the other. For example, you can have something like an alkene, or maybe an alkane. It has methyl groups, it has maybe something like a bromine, it has something like a methoxy group. What we're just going to do is to number them so that the, for example, like whether it's the bromine, for example, bromo, will have, you're going to start from that side as to give alkyl group and ethyl group lower ranking, but you're going to be saying those examples. So alkyl group, halogens, and ethyl groups do not have a priority over the others. You're just going to arrange them alphabetically. Now the thing is, if you're going to have an alkyl group like a methyl group, you're going to use alkyl like methyl, ethyl, propyl, and the rest. If you're going to use a halogen, for example, like if you've got a fluorine, then the name will change to fluoro. I'm putting halogeno. It means it will be ending with NO, like for example, fluoro, chloro, bromo, iodo, something like that. Yeah, that's what it means by halogeno. And if you're going to have something like an ethoxy, propoxy, butoxy, the name will change. That substitute will be called an alkoxy, something like that. Yeah. So this is the priority, and this priority table is very, very important. If you're going to use it, then you will be able to know how you can name organic compounds. So that's what you're going to be using. And as I mentioned, from now on, we're going to be using the bond line structures, as opposed to those CH3, CH2, CH, all those kind of things. We're going to be using the bond line, those zigzag and implying carbon, hydrogen is being implied, and something like that. And you're going to be using those bond line structures. The previous video just showed you how to convert the normal Lewis structure into the bond line structure. So I believe you can see the board well, and you're going to be proceeding from there to name the organic structures. First of all, we'll begin with alkenes, alkynes, and also benzene compounds. We'll begin down here. Probably we'll begin from number 6, whereby we'll start with a benzene, things like alkene, alkyne, and a benzene containing these are the substitutes, and then you start to moving a little bit higher to see, for example, if you've got an amine, it's got a benzene, it's got these kind of things, how you're going to name something like that. Yeah, we'll stick to simple structures, and I believe you'll be able to enjoy this naming. Okay, thank you very much. We'll proceed from there. Okay.